Hey guys, we are looking at right now being able to make an opinion and prediction based off of a sample of a population, okay? So here's what we need to know before we can even do this prediction and we can make a prediction. We need to know what population is. We need to know what sample is. The whole point of a population and a sample is to go over here and make an inference. We got to interpret the information and make an inference. When you're making an inference, there's two types of inferences you can make. You can make a biased or an unbiased, okay? So an unbiased represents the population, is a representative of the population. It should be random and large enough to provide accurate data, and you can tell that accuracy because it's proportional to the population as a whole. A biased sample is one we talked about with band. If we were going to ask band students what they like to do as their extracurricular activity, they're going to say probably band. If we're going to go out and ask football players what they like to do outside of school, they're probably going to say football. So we don't want to just limit our sample to that specific population. And being able to recognize when things are biased or unbiased is a good trait to have. For example, if we're looking at the news today and they're out there on the streets interviewing people, what kind of people are they interviewing? Are they representing our population as a whole? Or are they only looking at specific sides to get a point across? So make sure you're looking at unbiased to get our population as a whole, or the population. All right, let's get into our examples. Our first example is you want to estimate the number of students in a high school who rode the school bus. Which sample is unbiased? So is a good representation is random. Okay, 4 students in the hallway. Random in size. 4 students in the hallway is not enough people to say if it's a good population sample. B, all students in the marching band. That's biased because you're only looking at a specific population, marching band. 50 seniors at random. Biased because you're looking at seniors specifically and not looking at all the other. There's 3 other grades. Seniors aren't the only ones. And another thing you could go with this is marching band and 50 students aren't a good representation of a high school. You need a little bit more. D is your best choice because 100 students at random during lunch is the best choice. You're getting random answers, not being picky. You get who you get, and 100 is a lot better than 4 or 50, or a marching band is less than 50 for sure. This is y'all answer. Okay, now what if we want to estimate the number of seniors in high school who ride the bus? Which sample is unbiased? So if we're wanting to just narrow that down to seniors, we're going to have to go with choice C because it's specifically looking at seniors by itself, not all the other students. You want to estimate the number of seniors this time in high school who ride the bus. So you're only going to look at seniors as the unbiased because seniors will know. Now, let's look at it this way too. You want to estimate the number of 8th grade students in your school who consider it relaxing to listen to music. You randomly survey 15 members of band. Your friend surveys 15 students whose name appears on an alphabetical list of 8th graders. Which sample is unbiased? And explain. Well, your friend, the alphabetical order is unbiased because it's not a specific part of our population here at Holmes. Because it's not a specific part of our population. Unfortunately, the alphabetical list isn't always the best option, but it's better than going just to one classroom and surveying people. All right, next example. You want to know how the residents of a town feel about adding a new stop sign to determine whether the conclusion is valid. So if we're trying to determine, we're looking for proportional. Okay, that means fraction equals fraction. You survey 20 residents who live closest to the new sign. 15 support the sign and 5 do not. You conclude that 75% of the residents of your town supports the new sign. Okay, is 20 residents enough? Is choosing people that live closest to the sign random? So determine whether this conclusion is valid or not. Valid. Well, I don't know about you guys, but if I live closest to the stop sign, I probably would support it because everybody's driving all crazy. So this is biased. Biased because they're just choosing people closest. Part B. You survey 100 residents at random. 40 support the new sign and 60 do not, so you conclude that 40% of the residents support the sign. This one's unbiased. Because it's random. And has a good amount of people surveyed. All right, next set. In example 2, this is example 2, each of 25 randomly chosen firefighters support the new sign. So you conclude that 100% of the residents of your town support the new sign. Is this valid? Nope. Because they're choosing only firefighters. It's biased because they're only choosing firefighters. They're choosing a very specific sample. All right. Example 3. You ask 75 random chosen students how many movies they watch each week. There are 1,200 students in the school. Predict the number n of students in the school who watch one movie each week. So it's proportional. Remember, proportions are fraction equals fraction. Okay? So we know that in our pie chart, we are looking at predicting the number of students in the school who watch one movie a week. One movie a week is green, and that's 21 out of altogether we have 21 plus 24 plus 30. 4 plus 3, 75 total, okay? The school has 1,200 total, and you're trying to predict how many. Cross product, 12 times 12,000. Gotta get a calculator for that. 12 times 12,000. Sorry. 14400 equals 75 times n. 75 times n. Divide by 75. Divide by 75. And our prediction is that 192 students watch one movie a week. Students watch one movie a week. There we go. Okay, example 3. This is example 3. Predict the number of students in the school who watch 2 or more movies a week. So 2 or more movies. 24 out of 75 equals number of students out of 1,200. 24 times 1,200 is 28800 equals 75 times n. Butterfly cross product property. Divide by 75. Divide by 75. And 384 students watch 2 or more movies a week. Done. This is the big 4. I want you to be able to use your data to predict the future. All right, here's your on your own problems. Go ahead and get started on them. When you're ready to check your answers, go ahead and press play. Here is what we should have got. I should see cross product property for number 2. Answer this essential question. And I hope you guys are having a great day. Bye, guys.